Welcome to my video. My name is Curtis and I'm here today to talk to you about solar generators. In particular, I want to explain how solar generators can be used to power our astronomy equipment when we're out in the field at a dark site where we don't have easy access to AC power. I will go through the basic attributes of solar generators and show how those are different than a simple lead acid or lithium battery. In the second half of this video, I'll explain and show to you how these can be connected, different ways they can be connected to the astronomy equipment that we use. Now, there are many different solar generators on the market. If you check on Amazon, you'll see new names pop up all the time. I have here with me 3 different solar generators, 2 from Jackery, which is a well-known supplier of solar generators. This is their 1,000 watt-hour model. This is their 518 watt-hour model. And here is a model from Maxoak's Bluetti, their 500 watt-hour model. There are differences among these, but most of the features in solar generators are the same. Both Jackery and Maxoak's are the more well-known models out there, but there are many to choose from. So let's dig in and go through individual features of solar generators, one by one. First of all, solar generators come in many different sizes, price ranges, and capacities. You can find them from 160 watt hours to over 2.5 kilowatt hours. So there's a model out there for your power and your price range if you're interested in these things. Solar generators are what I like to call all-in-one solutions for power in the field, which means they can pretty much supply any of your power needs while out at a dark site. So the most important power need that we have and typical is DC power. Solar generators typically will operate at around 13 volts, plus or minus a little bit, depending on the current that you draw. And the DC power will come from your cigarette lighter plug socket. They all have a cigarette lighter plug socket with a 10 amp maximum current capacity, which is more than enough for pretty much any solar astronomy application that I can imagine out in the field. The other nice thing about the DC power from these solar generators is that it is regulated, which means that the voltage will remain fixed at about that same state all the way till the solar generator shuts down. In contrast, if you use a lead acid battery, fully charged will be about 12.6 to 12.9 volts. As you draw capacity out of that lead acid battery, the voltage will drop slowly till it reaches about 12.06 volts, at which point you've used 50% of the capacity, and at that point, if you try to draw any more capacity out of the lead acid battery, you will start to damage the individual cells. So you get about 50% capacity out of a typical lead acid battery, but you will get the full capacity, rated capacity, out of these solar generators. So why is that? Inside are lithium ion cells. Obviously that provides the power. The lithium ion technology used in solar generators is called NMC, or lithium nickel manganese cobalt oxide. That chemistry is chosen because of the high power density to weight ratio. And that's why you will find the NMC cells not only in solar generators, but in electric cars, e-bikes, and in power tools, because you get more power for a given weight. These things don't weigh too much. This is a 518 watt-hour model and it weighs about 13.3 pounds. The Maxoak's 500 weighs about 13.6, and the 1,000 watt-hour model from Jackery that I had on the table before weighs 22 pounds. So you get a lot of power to weight ratio versus 50 amp hours, which is about 600 watt hours out of a lead acid battery at about 63, 64 pounds. Now, the other thing in solar generators is they have, and all lithium batteries for that matter, is they have a battery management system inside. And that is a smart circuit that pays attention to the voltages on the individual lithium cells inside, make sure that the cells are balanced one against the other, that no one cell gets drawn down in voltage lower than the others. It also makes sure that as you draw power from this solar generator, when it reaches the point that the voltage is at the lowest allowable level for the individual cells, it will automatically shut the solar generator output down. So when it gets down, when the display reads 0 capacity, it will suddenly shut the power off. Now you can watch as the power is going down on the meter, and you can know when you're about to run out of power. Unlike a lead acid battery, it'll just keep giving you current or power as long as you keep it hooked up to your equipment, and you can damage the cells by trying to draw it down too low. So the 518 watt-hour model will give you its full capacity, and same with the others. And typically you'll get somewhere around 92% because you do lose some power in the circuit that is used to voltage regulate, and there is some internal resistance and some power on the display. But you typically get about 92% of the rated capacity out of these things. So you can get all of your power, DC power, out of the cigarette lighter plug, and some models have additional smaller plugs on the side. Like this one has 2 7-amp regulated outputs. This uses a 6.4 by 1.4 millimeter socket, which is not what we typically use for our astronomy equipment, but you can get an adapter, and I'll put a link to the adapter down below. And that will allow you to go from the 6.4 by 1.4 to a 5.5 by 2.1 millimeter socket. Now the Max Oaks also has 2 smaller outputs. Those are 5.5 by 2.1 millimeters, so you don't need an adapter. Theirs is a maximum of 3 amps for those sockets, and they're not voltage regulated. So you have to pay attention to the specs from the different solar generators to see whether they have additional outputs, and if so, whether they're voltage regulated and what their current capacity is. Now, when we're in the field, sometimes we need AC power. Now, what would be the case where you need AC power? For instance, my laptop from Dell cannot be charged or powered using a DC adapter. Dell has designed their laptop so that it requires to use their AC charger and only their AC charger. So in the field, I need AC power. Well, inside the solar generator, you typically will find a pure sine wave inverter with at least 1 and sometimes 2 or 3 AC outputs. And so when I'm in the field and I'm running my laptop, I can just plug the AC power supply for the laptop right into the sockets here and power my my laptop with AC. If you want to power any of your equipment with AC, you would use the AC outputs as well. In addition to DC, AC, there's also a series of USB power ports on the typical solar generator, and those vary. USB-A, USB-C, quick charge, it depends on the model. You have to look for those, but they're very convenient. They can be used, and I've used mine to recharge my cell phone in the field. They can be used to recharge a laptop, and in some cases, if it has the right adapter, it can be, or the right plug, it can be used to recharge a laptop. An additional feature is a LCD display. These vary by model. This particular one will show you the capacity in 1% increments, so from 0 to 1 all the way up to 100%. It will also show you how much power you're drawing in watts, and if you're charging, it'll show you how much power you are charging the generator with. Now, let's talk about charging. When you reach a state where you need to recharge, so you've run this during the night, maybe you've depleted the capacity, or you want to take advantage of the time during the day to recharge and top it off. There's 2 ways to recharge. The recharging circuit inside allows you to use the supplied AC inverter or AC charger to plug in through this socket and an AC outlet if you have access to the AC, and recharge the solar generator. Typically, these solar generators, all three models that I showed here, will recharge anywhere from 6.5 to 7.5 hours. Now, you say, how can a 1,000 watt hour generator recharge in about the same time as a 500 watt hour? That's because the charging circuit in the 1,000 watt hour model will allow a much higher charging current, and it comes with a much beefier AC power supply, so it can charge it in about the same time as you can charge the 500 watt hour models. Now, the other way to charge these, and you use the same port, is by a solar panel. And you can purchase solar panels separately of the generators. They don't come with a solar panel unless you buy a package with the solar panel involved. And you would simply just plug the cable from the solar panel into the same place you would plug the AC charger. And the nice thing about the solar generators is that they have an internal solar charge controller, typically an MPPT solar charge controller, which takes care of taking the current from the solar panel and recharging the battery. Lithium cells inside. If you had a standalone lithium battery, you would need a separate solar charge controller to go between the solar panel and that battery. But that's all built in to the solar generators, which is why I call these an all-in-one solution. What other features did we miss? Another nice feature of the solar generator is what's called pass-through charging. So let's say I've run this during the night. During the day, I'm recharging it either with the AC charger or a solar panel, but I also want to recharge my laptop or my cell phone or both. Well, while I'm recharging this with the solar panel, I can be drawing power out of the AC outlets and the USB outlets and recharging my other equipment at the same time I'm charging this. Now, of course, as you draw power out, it's going to take longer to recharge the cells in here. So keep that in mind, but you can do pass-through charging, which is a convenient feature of these things. And I think that's about it for useful astronomy applications. These things do come with a flashlight type battery, flashlight on the side. The Max Oaks actually has a more useful flashlight or light. Oops, sorry, got to turn it on first. Much more useful, but you know, this is not something we typically would be using out in the field while others are trying to do astronomy. And the nice thing about the Max Oak, which is different from the Jackery, is the fold down handles. So you can see these handle fold up to carry, fold down, makes it easier to stack. The Jackeries are a molded in handle. This also has a wireless charger on top, so if your cell phone is capable of wireless charging, you can just set it on top and wirelessly charge it. This is only 10 watts though, so keep that in mind. It'll take a while to recharge. All right, so those are the features of solar generators and how they differ from a simple lead acid or lithium battery. Now, how do we actually connect these things to all the equipment that we use in the field? Let's take a look at that now. So now that we've reviewed the basic attributes of the solar generators available on the market, how do we connect this and how do we connect these and use these with our Astro equipment? Well, the short answer is it's basically the same as connecting a regular lead acid battery or a lithium ion battery, with two major exceptions. First of all, the solar generators, as we discussed, already come with the built-in power ports. They all have the cigarette lighter plug with 10 amps. Some may have additional plugs and others do not. But with a simple battery, you'll have to either buy a battery box that will have a cigarette or one or more cigarette lighter ports on it, or you can build your own battery box with the kind of ports that you prefer to have. So that's the first difference. The second difference is, suppose we want to run AC power in the field. Why would we do that? Maybe our laptop, we need to run that off of AC, or in some cases, you may want to run your mount with the AC power supply that came with it. Well, the nice thing about the solar generators, and the reason you're paying more than you are for a simple lead acid or lithium battery, is that it has the built-in pure sine wave inverter, and you can simply plug in your AC power supply into the socket, turn on the AC with the plug here, and then you supply the AC power directly to your mount or your camera or whatever piece of equipment you prefer to use AC. Now, this particular Jackery only has one AC outlet. The Blue Eddy has 2 outlets, and you saw the 1,000 watt-hour Jackery had 3 outlets. So if you need to use AC for more than one device, you may want to consider that when you choose which model of solar generator is going to work for you. So in most cases, we don't want to run with AC, since the inverter chews up a little bit of power, and you might be only 80–85% efficient in converting from DC to AC and then back to DC. All right, so now let's assume we're going to power the rest of our equipment with DC. How do we do that? Well, when we buy mounts and other equipment, at least in the old days, they would come with these cigarette lighter plugs and maybe a long cable. This is a very long cable with a 5.5 by 2.1 millimeter adapter on this end. So this would plug into the mount, it could plug into the video camera or other piece of equipment, and then you would plug this into the socket there. But what happens when you need to power multiple things? You need multiple cables, and maybe you have a dew heater like this Astro-Zap, which comes with a cigarette lighter plug on the other end. Well, for that to work, you need to have a splitter. And splitters come in 2, 3, and 4 outlets. And very simple, you plug connector into here, you plug this into here, and you can plug the other ones, and then you route your cables, your power cables, to where you need to run them. This is basically, I have used this for like 10 years with a lead acid battery and a battery box. Works fine, just a lot of cables. These are not the greatest connectors, power connectors, but they work. So that's way number 1. Nowadays, people are moving to more elegant solutions, and that involves using a power hub. This is an example of a power hub from Pegasus Astro. The purpose of a power hub is to have single power in and multiple power outlet ports on the same device. This has internal fusing, a short circuit protection, over voltage protection, so that it will shut down to protect your devices. Whereas with these devices, you're counting on the fuse that's located in the base of the cigarette lighter plug connector. So how does this get connected? This can be connected with one of these cigarette lighter adapter plugs, a single plug. That way we get rid of the splitter. Now you have power into the power distribution block. And you can then connect with whatever size length cable you need. This will come with multiple short cables. Those cables plug into one of the 4 power outlets here, and they can be routed to your equipment. If you have a dew heater, the dew heater strap can connect to one of the 2 dew heater ports, and if you have a long distance, you're going to need an extension cord for that. Now, the nice thing about these is they're lightweight, they're compact, and they can be mounted on top of many people like to mount them on top of their telescope, so that the cable routes are very short. In my case, I mount it on the side of my tripod, because I have through the mount cabling and power distribution, so I can still keep things short. So These are very convenient. You can get them as just a power distribution hub alone. You can also get them, this one here has USB hub capability as well. Now the only downside to these is that they are pricey. You can spend several hundred to $400 or $500 for these, and maybe some people don't want to spend that amount of money. There is an alternative if you don't want to spend that amount of money for an astronomy-based power hub like this. And that's what people in the ham radio hobby have been using for years. This is a rig runner. These are made in the US. These are power distribution hubs. It has a single input port and multiple output ports. These are, as you can see, individually fused. You can change the fuses. The input power takes 40 amps, which is way more power than we're going to use in any of our applications. And in fact, these things only put out 10 amps total current. So how do you connect this? Well, before I talk about how to connect this, these are also nice and lightweight. They're pretty sturdy, well built. This can be mounted on top of the telescope, or it could be mounted on the leg like I mount the Pegasus power box for my application. The other thing to note is the connectors on this. These are Anderson power pole connectors, which as you look around these days in astronomy equipment, you're starting to see more and more vendors supplying things with Anderson power pole connectors. That's because these power pole connectors can take more current than the 5.5 by 2.1 millimeter connectors that we currently use. These also have some other advantages I'll show you in a minute. So how do you connect this? So first we're going to need a cigarette lighter plug adapter. A single one of those plugs in here, and input power goes in here. And there's a nice click to that, and it's a nice sturdy connection, but you can pull it apart. It takes a little bit of effort. The other nice thing about this, in addition to being able to being rated at a higher current capability than the 5.5 by 2.1 millimeter, is the fact that you cannot, in the dark, plug this in backwards. So you cannot reverse polarity connect. It will only connect one way and it'll lock in. Okay, so if I need to power multiple things, I just need to get cables that have our 5.5 by 2.1 millimeter connector on one end and Anderson power pole connector on the other end, and I can begin connecting as many of these as I need and run them over to the piece of equipment that I'm trying to power, just like with the other power distribution hubs. So rig runners come in multiple sizes. They come in, this one has 5 outlets, 1 inlet, 5 outlets. I think they come in 4, 7, and more than that. They also come, higher end models have a USB output, and they also, you can get them with a voltage display as well. What I like about this model here is it's only $75. So that's a lot cheaper than several hundred dollars for the astronomy built applications. And if you want to connect a dew heater, then you'll have to do it through a separate connector. If your dew heater has, where's my dew heater? If your dew heater controller has this, you can get one of these. You can connect it this way. If it were me, I would not do this. That works. If it were me and I were going to use this Anderson power pole, I would cut this and put 2 Anderson power pole connectors on the end of this and just make it connect just like that. Another nice thing I would point out about these rig runners is that this model has the outputs horizontal. They also make a same model with the outputs coming up vertically. So whichever way you like to route your cables, if this is more convenient for you, this is the way to go. If you want them to come up for some reason, that's another way of doing it. Okay, well, there's a lot of stuff here, but that's how you can connect these things. Well, like I said, they're actually more convenient to connect than a simple lead acid or lithium battery because they come with all the built-in connectors. Oh, and one last thing I forgot to mention. As I said before, the Blue Eddy comes with 5.5 by 2.1 millimeter plugs as well. So these supply up to 3 amps of current, which is handy. These are not voltage regulated, but they will provide the voltage that you need unless you're trying to draw too much current. This Jackery uses different connectors, so this plug won't work here, but you have to buy one of these adapters. So this is a 6.4 by 1.4 millimeter plug adapter to 5.5, and so there you're in good shape there. So you can actually use these, and what's nice about these is these are 7 amp voltage regulated connectors. So you can use the 2 of those, you can use that. So there's multiple ways of hooking these up. So I hope that helps you figure out how to use these when you're out in the field. The biggest issue in making the transition from a lead acid battery to a solar generator is the upfront cost. The Jackery 1000 watt generator sells for $999. I've seen it on sale for as low as $850. The 500 watt model, $499. I've seen it on sale for as low as $425. And the Blue Eddy it sells for $400. I've seen it on sale for $380. So if you're going to buy one of these, please watch for a sale. Don't pay the full retail price because they do run sales quite often. Now compare that to the cost of a good quality 100 amp hour deep cycle AGM battery, which is about $200. So when you compare that to the 500 watt model from Jackery, you're looking at a factor of 2 differential. But you need to take into account, by the time you add the pure sine wave inverter, the MPPT charge controller, USB ports, DC ports, power meter, LCD display, and a box to put it all in, along with an AC charger, you're going to add about $200 additional to the cost of the AGM battery. It's not going to be lightweight like the solar generator. It's not going to be in a very nice package like the solar generator. So you need to take that into account when you compare the cost differential between the two. I'm not saying anything's wrong with AGM batteries. If that works for you, have at it. For me, I've moved on to solar generators because I like the convenience of the all-in-one package that comes with a solar generator. I hope you enjoyed this video and learned something useful from it. If so, please hit the like button. You may also want to hit the subscribe button so you can be informed when I upload future videos. In the meantime, I encourage you to visit my website, californiaskies.com, where you will find more useful information on similar topics. Until the next video, thank you and goodbye.